So this kit, this is another one that I saw Big Clive build. And it's the first clock kit that I've seen that I actually quite like. And what I especially like about it is, if we break all this open, I haven't opened any of this yet. This is an unboxing stream now. What I like about it is it's got these big, huge displays. What size are those? Those are 35mm. And there's actually something interesting about these, which I'll show you. Because they're not actually 7-segment displays, they're cheating. They are cheating in order to be that big, because you can't make LEDs that large. So, yeah, no problem, Sophinia. So I'll show you what they've done here. Let me grab, I might just be able to do this by hand. We can just pop that off. We'll see a secret. Am I going to need a prying tool? I'm going to need a prying tool. There's one. And there's two. There we go. And what they've actually done is this is actually just a light box. Let me just focus. So we've got this light box like that, and if I grab a light, you can actually see, whoops, that's a bit overpowering, isn't it? You can actually see that it's just a light box. And then that, underneath it, has this board. And as you can see, it just has some tiny little LEDs that shine into the light box. And so that's what they've done. So it's technically not a 7-segment display. It's a load of LEDs that have been wired into this light box style arrangement. It's quite clever. Let me see if I can... yeah, there we go, I can put it back together. And let's just get my focus back under control. Right. So let's carry on unpacking this. So we've got 4 of those. We've got a circuit board. It's quite a dense circuit board, actually. There's quite a lot to see on that. And there's 2 big controllers. So we've got 2 chips here. Let's show what those are, just for those of you playing along at home. We've got focus. We've got that guy. That's a DS1302. That's a timekeeping chip. So this does all of the clock functions in this guy. It counts time, it counts the date, it does all the calendar functions, all of that jazz. Yeah, same here, Sophinia. And then here we've got just an STC. This is a bog standard no frills microcontroller. So this thing will be driving the LEDs. So this thing will talk to this chip and it will say, what is the time? This chip will respond and say the time is XYZ, and then this guy will output the appropriate signals to make the LEDs light up. Very simple, really. So let's build it. And we've got a case for this as well. The whole thing is 5-volt powered, and it's come with this USB to barrel jack connector. However, what I want to do is, once I've built it all, I'm going to take apart this power bank I've bought, and I'm going to hotwire this power bank into it. Because this power bank is very simple, and you can do quite a lot with these. Buying a £1 power bank from eBay is a very cheap way of getting yourself an 18650 lithium polymer battery. So that's an 18650 LiPo cell, and it comes effectively free with a nice little 5-volt USB regulator and charger circuit. So we can take all of this to bits and we can hotwire it directly into our clock. And then instead of having a stupid dorky USB cable to power our clock, we'll have a nice little rechargeable lithium battery, which will be fun. That's the plan. So let's start building the clock first, because we need that before we can do anything with it. So, I mean, this thing says it's 2600 milliamp hours. Whether it is or not is debatable. But even if it's, even if it's half that capacity, it's going to power a poxy little clock for probably a week without recharging. So let's see what we've got. Wow. Okay, this is mostly instructions on how to program the clock, I believe. They've even got a schematic there, which is nice of them. That's kind of cool. Luckily, they've actually marked out all the components on the board, so this will be quite easy. Let's put that to one side. I don't need instructions. We've been through this before. Right, that's the case for it, which we'll build last. I hate doing those. And we've got some chip sockets, and then we've also got some black film here. And what that's going to do for us, obviously these are quite light when they're not lit, but if you put the black film in front of them, it smokes the screen out so you can see the digits more clearly. So that's what that's all about. Right. Okay, so we are going to start with our chip sockets on the back, I think. So let's get set up. I'll put that in there. It's always best to start with the biggest components first. No, actually, I've got that the wrong way around. We do the smallest components first. I'm going to do my chip sockets first because that's the kind of person I am. I can build. I'm the one building this. I can do it however I please. So that is my decision. Right, and whether I come to regret that or not is remains to be seen. Oh, that's annoying. Look at that. The camera is at such a height that it's just between focal steps. There we go. That'll do. Right. So let's drop you in. So we've got half moon there, so we know which way around our chip is going to go. And of course, all the legs are going to bend when I try and put them in. I'm going to need some tweezers just to, there we go, encourage those in place. Right, and I'm just going to bend two of those legs outwards just so it sits flat. And now we're just going to drag solder across all of those. And while we're doing on this, hopefully we'll be able to explain a little bit about some of the electronics that we see on this thing and how it works. So let's whiz through these. Am I turned on? Nah, I forgot to turn the soldering iron back on. Professional stream. Right, well, while we wait for the soldering iron to warm up, let's have a closer look at this board. So our two controllers, we've got our main CPU, our microprocessor goes here, and we have the clock chip here. By the clock chip, I mean the timer chip. And then we have a frequency crystal there that actually helps it keep time, so that it provides its oscillator. Then we've got a bunch of 10K resistors. What do those look like they're doing? Those 10K resistors. Those 10K resistors go to... it looks like those are going to the LEDs. So that being the case, I wonder what the 330s are doing. They are going to... They're also going to LEDs, I think. It looks like they have resistor arrays going to and coming from the LEDs. The displays will be what is called multiplexed, and what that means is if we add up all the displays, so these are 7 or technically 8 segments because we have 7 segments making up the digit 8 there plus 1 for the decimal point. So we'll have 8 pins on the bottom of this, 8 legs and a common. So we've got 8, 16, 32. So we'd have 32 pins. Now this thing is not going to have 32 outputs on it. So what it does is it runs its outputs to a couple of transistors and it only lights up one of the displays at a time. And it sequences between them. So it will flash up a number on each one in turn and just chase through it. And it'll do that fast enough that you can't see it in action. Except sometimes you can. If it's a particularly bad system running at a very low clock speed, we'll actually be able to see that flicker and it'll be really horrible and flickery. However, with a bit of luck, the clock speed will be high enough that we won't actually be able to see the multiplexing in action. But the camera that we're looking at here is 60 frames a second, so it may well be able to see the multiplexing, so that'll be fun. Right, I think my soldering iron should be up to temperature by now. It is. So let's quickly whiz across these. Whoop. I remember when I was building my LED cube and I had about 8 of these ICs to do. It took forever. It was the The LED cube looked very exciting, but was actually extremely labour intensive to build. We may be revisiting that in a future one though. I want to do a video of fixing the LED cube, because the LED cube is currently not in very good condition. A load of the LEDs on it have gone pop, and I need to replace them. Which I shall probably do. I don't know if I'm going to do that live on stream or whether I'm going to do a video for that one. Because I'm not sure exactly what I'm doing with it. We'll find out. Whoop. Now I'll just get rid of that solder bridge there. There we go, that's fine. There we go, and oh, I did a very poor job of getting that flat. Nah, that doesn't matter. That'll be alright. Okay, let's get our other chip socket on. And maybe this one will be flat. Right. I'm just going to do one of those, and now I'm going to hold it flat. And then I'll do the opposing corner and hold it flat again. This is what I should have done on the first one. And then I can make sure that the whole thing is actually flat against the board. Not that it matters, but you know, it's always nice to do a good job. That's the fun part of these, is just seeing how neat you can make the whole thing if you're trying. There we go. So that one is nice and flat on the board, unlike that one, which is not very flat on the board. Okay. Those are the chip sockets done. Let's have a look at the other components. So I think we're going to do all the resistors next. We'll get those done and out the way. The resistors are boring. Ah. Ooh. Oh, there's all kinds of things built up in here. Got some buttons. Oh, I remember. This thing is fun. This thing has got like an ambient light sensor on it and stuff like that, so it automatically adjusts its brightness. Oh my lord, this button is so stuck. There we go. Let's make a little pile of components. Yeah, there we go. So look, we've got a little ambient light sensor there. Some buttons, and I think we have a temperature sensor among these somewhere as well, which will be fun. I might even put it all on camera shot so you can even see what I'm doing. Oh, hey Hellkith, how's it going? How you doing? Oh, it's a Hellkith birthday raid. Is it your birthday, Hellkith, or is it someone else's birthday that you're appropriating? It's yours. Happy birthday, Hellkith. How are you doing? Are you having a good day? What's that? I don't know what that is. That's some kind of I'm not sure what that is. That can't be a temperature sensor. We'll find out. We'll find out. Okay, right. Let's do our resistors. These are very helpfully actually labelled. So these are our 10k resistors, and these are our 330s. So unsurprisingly, the 10ks go in the 10k slots. So let's cut those out. Breath of the Wild, Deathless File. It's the end. Oh, find its end at Waterblight. Oh, did you die? Xena diode. Oh, it could be. Hello, Anna. How you doing? That is a good shout. You're right. It probably is a Xena diode. Have we got a Xena on here? I can't see. Where's the schematic? We'll see it on the schematic very easily. You died. Ah, sad story, man. Commiserations. Can I see a Xena on here? No, I can't. Well, it might not be marked on here. We'll find it. If we have it, it'll be on here somewhere. What about the board layout? Can I see it on there? No, I can't see any diodes on there at all. What is that doing then, I wonder? Well, I'm sure we'll find out. Low reset time diode. Yeah. Well, it's whatever it is. It's germanium, but it's not our oscillator crystal, because we got one of those already, which is this guy here. We'll probably find out. As we run lower on components, I'm sure it'll make itself known. So, right, let's do our 10k resistors. Let's break these guys open. And let's get all of these on the board at the same time. Get them squared away. Get her done, as Slint would say. Who's sadly working tonight? Sad Panda. He cannot be with us. Rest in pieces. Whoop. How you doing, by the way, Anno? Oh, it's Lyndon as well. How are you doing? Filling space in the bag. Right, that in there. How many of these do I need? I need 3, 4, 7 of them. We've got one spare. And I'm going to leave the one spare on the 10k marker so I don't have to look it up afterwards. Oh yeah, I'm a big fan of Big Clive. He's actually built this kit. I actually watched his video doing this exact kit and I was like, I want one of them. Because I've seen various clock kits on eBay before, but none of them I really liked. I didn't really care for the design of them. But this one actually looks really nice. I've got one that's also super cool that, again, he also built. But I'm saving that one for another stream. I'm not blowing 2 decent kits for one stream. Looks familiar. Yeah, that's right. Because I just showed off. We've got the big displays, and these, of course, are the light boxes with the LEDs in them. And I just showed that off to the stream as well, which was kind of interesting. So, right, stick that guy in there. Get in there. Get in there. There we go. Right, solder them all in. See if there's a Xena in his kit. Yeah, go for it. That'd be interesting. Because, yeah, that is. I am slightly curious about that because I think you're right. It looks like a Xena diode. It looks like a germanium Xena diode, but I can't see anywhere on the board where it's actually called for. And to a certain extent, I'm not quite sure what it would be used for. I'm not sure where in this circuit would require a Xena diode. Whoop. Might be part of its power supply, perhaps, but then because the whole thing is powered from 5-volt USB, there's probably, well, I can't see any regulation in this thing at all. I don't think it has any power regulation. I think it just all runs hot off of the 5 volts. They are a lot of fun, Hellkith. That's why I do them. Look at that. This quality. Let's fix those. I should have done one side. I should have done one side, then flatten them. Oh god, this is going to be horrifying. Hey, Kira, how you doing? How's it going? Aki, 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 as the cry goes out. Oh, damn it. You know what, that guy's just going to sit up. If he's got the power to sit high on the board, then power to him. He is resisting, as the very cheesy joke goes. That one there. There we go. I'm just trying to get these resistors to sit vaguely flat on the board, and I'm doing a very poor job of it. There we go. Let's try the other side. Let's see if we can get those ones flat. You know what? That'll do it. That's good enough for me. Xena thing is the temp sensor. Ah, okay. I figured the temp sensor would be one of these guys, one of these TO47 packages. That makes sense, though. That makes absolute sense. All right. Must be coming from Chime. Secret packages being sent around to the gang. There we go. It's probably some kind of. I'm guessing. My guess is it's coffee. If it's to do with Lyndon, that'd be his cup of tea. Please stay. Right, those are our resistors. So we've got another set of resistors to do, but I'm going to do them in a minute because I'm bored of resistors already. Let's put something else on the board. Odd that it'd be the same form factor as a diode. Yeah, it could be. It could be. Yeah. Don't know. I mean, it might just be a thyristor rather than a Zener. Just a thyristor. That simple. Just literally just a really basic thing. Just the resistance goes up and down with temperature. So, right, split that back over again. Right, let's do our clock timer arrangement down here. So let's put on my crystal, my frequency crystal. I'm just going to adjust the camera slightly because the camera is casting a shadow over the board. There we go. Got to separate these legs out. And just put you in there and lay you down on the board like that. Now let's just fix my focus. I think we're slightly out. There we go. And bend those sideways so it doesn't fall out. And just stick a blob of solder on one leg there while I sort that out. Alright, let's get that settled. There we go, and do the other one. And in come the snips. Whoop. There we go. There's our oscillator crystal. I don't watch AVE. I've heard lots about him and I need to check him out. Mainly I watch EEV blog and Big Clive. Oh. But I've heard a lot about AVE and I've been meaning to check out his channel at some point. Right, so C4 and C5. C4 and C5, 22 microfarad resistors. So it's probably, that'll be these guys. And close up for posterity. There we go, 22 microfarad capacitor. Whoop, 1, 2, 3, 4, 5. A loop. So I've got two of those are going to go in there. So these are decoupling capacitors and they make sure that there's no DC voltage going into our frequency crystal, because that would be bad. That would cause it to die. So these guys keep it nice and isolated and make sure that we can only get oscillations there, not a forward bias. You and you, there we go. Yeah, that's right. As I say, I've heard much about him, but never actually watched him. I do need to check him out though, because I do like sitting and watching the electronics engineering channels. That's my jam on Sunday afternoons. I sit and I have a game running while I watch electronics engineering videos. Let's do the other capacitors while we're here. So what other capacitors have I got? I've got that guy and that guy. That's another 22. What's this one? That's a 104. So that is that's 10 and 4 digits. So that is 100,000. So that 100,000. So that will be 1 microfarad, I think, or 100 mic, if I've got that right. If my brain is working correctly. So either way, C1 104. There it is. So that guy's going to go in there. Get in there. Whoop. Solder him in before I lose him. Slight bridge on the crystal. I will check that. Oh, I can see what you're talking about. I don't think there is, but I will give a close-up of that in a sec. It's difficult to get the lighting right tonight. Normally I would have Normally, if I was recording for YouTube, I'd have this bad boy lighting up everything. I'd have that at such an angle so you could see what's going on. However, this guy won't last for the whole stream. Right, however... No, those are not bridged. Here's the close-up, just to put your mind at ease. There we go, so yeah. There's no bridge between those two. There we go, they're alright. It just looks deceptive because of the lines and stuff. Flux is getting in the way. Yeah, that's right. Right, so what was that? That was a capacitor. Whoop. Get out of there. Alright. And so where's our last 22 mic? Ah! Just blinded myself with the light that I left turned on. Good job, Graham. Turn it over and get blinded. Yeah, absolutely. We'll just find that it doesn't keep the time. Okay, so I'm looking for another capacitor point. You know what? I don't think there is another capacitor on this board. I think that is a spare. I think that's a spare one. Although actually C1 and C4, there's got to be something else somewhere on this thing. Where's C2 and C3? With that being the case, other side of the board maybe. Nope. Well, we've only got one capacitor left, so no, I think they've just got their designators weird. Maybe they previously had a C2 and 3 and they took them out of the final design. So that must be a spare. I'm going to put that to one side. If if we've got any holes later on, we'll find it. Okay. Right. Next, I think we're going to get the last of the resistors out of the way. So how many of those have we got? R1 to R8. So we need 8 of these. And we've got 1, 2, 3, 4. 1, 2, 3, 4, and one spare. So let's tear out these resistors. Ugh. And I'm going to be good, and I'm going to remember to solder one side of these first, so I can make sure that they're sitting flat on the board this time. And we might actually have something that looks presentable. Unlike the 10K resistors that look like I shoved them in roughly with a hot glue gun. Clive would smack you, yeah. Or are you saying Clive would smack me because I pulled the end off of the resistor tape? Because I have seen that he cuts his. I can't remember what he said his reason for that was. He did give a reason, and I remember him saying that was kind of interesting, but this works. They are no longer attached to the tape. Ugh. Picking and placing is always the most long-winded part of the process. So when you've got a lot of repetitive stuff to do, it's best just to get on with it. Soldering. Yeah. Yeah, my soldering's not particularly on point, but then, you know, I think he mentioned this in his video about this project, is that the actual tented through hole, the through holes on these, the plated through holes, are very narrow. There's not a lot of tin to solder onto on this, which is making it difficult to get nice clean solder joints. Like, for example, let me grab. No, I don't have an example, because that one's also crap. No, I don't have an example of something that's got some larger solder joints on it to show you. However, yeah, the holes on these are quite small. And they don't have to be, they've got the room to have bigger holes, but nah. It's a cheap Chinese kit, what do you want? Alright, let's get the soldering iron on the go again. Yep. There we go. Right, and now, because I've only done one side, I can make sure they're flat. So I'm just reflowing those while pushing them from the other side. That's more like it. That's what they should look like. Save a few pence per board. Yeah, that's their profit margin, isn't it, though, on these things? A few pence per board. Have you seen the videos that EEV Blog put out about the 3-cent microcontroller which is used in a lot of really cheap Chinese electronics. A full-blown 4-bit microcontroller that costs 3 US cents. Unbelievable. Absolutely unbelievable. Yeah, very fascinating. It kind of shows how, it gives an insight into how they manage to make stuff so cheaply. It's very interesting. And that's one of the reasons why I find Big Clive's stuff very interesting, because he takes apart just really cheap electronics, which are not very interesting, but what's interesting is just all the cost-cutting measures in them and how they achieved it. So, yeah. Just skip on there. You just love soldering, the only part you enjoyed? Yeah. I did enjoy electronics when I was in school, but I didn't make very good use of my time there. I liked it, but I didn't really sit down and get into it. But there was less available. These days, with the advent of Arduino and stuff like that, it's so easy to make cool widgets. But back in the 90s when I was in school, there just wasn't much available. Right, what should we put on next? Let's put on these transistor packages. So these transistor packages will be handling our multiplexing. Yeah, the Poundland USB supplies. Yeah. So yeah, so these transistors will be doing our multiplexing. There's probably one there, one there, one there. Just 3 of them. Ah, interesting. See, that's kind of cool. There's 4 displays, but only 3 transistors. So I wonder if, I would imagine that the microcontroller has all of its lines going out to one display, and then the 3 extra transistors switch in the other displays. So that's kind of funky. They've saved having to use 4 there. Previous clock designs I've seen had 1 transistor for each display, one up top 2. Oh yeah, that's an 8550. You're correct. Well done. Well spotted. Nope, I lie. They do have 1 transistor per thing. So therefore, these are all 8550 transistors. So these are all going to go in, and they go in that way around. Let's just stretch them out between the holes. One. And 2. Oh, lost my chat. There we go. And 3. What would be really cool is if we have time afterwards to get the oscilloscope out and probe this thing while it's turned on to see if we can see the multiplexing in action, which is probably the most exciting thing this whole thing does, to be honest. That'd be kind of fun if we can just get the oscilloscope and just show you the signal waves going through it. Right, let's get some solder onto those. Whoop. Big Clive is worth watching even if you're not super into electronics, just because he's just so much fun to watch. He's so laid back. I love his style. He just talks about what makes something fun and exciting. And he builds stuff for the sake of it. Like, when you get into electronics, you kind of feel like you need to build something that's useful or does cool. Anno, could you oblige, please? Get these people a Big Clive link. But after a while, you kind of realise that sometimes it's just fun to make something that lights up, because something that lights up is cool. That's just fun. It doesn't have to do anything. It just lights up and it's cool, and you made it. That's what I like. There we go, there's our transistors. They all went a little bit wonky when I soldered them, but they'll be alright. There we go, that'll do the job. Do you like crappy pink USB chargers? Oh man, Anno, you were here too late. The first thing I built on stream today was an LED bulb. which does actually work. If I just turn my camera around for a moment and point it at the ceiling, this LED bulb here, we made that at the start of the stream. It's one of the big Clive LED bulbs with a capacitive dropper power supply in it and everything. It's awesome. So yes, it has the death trap power supply in it, which I explained the theory of operation on. So that was fun. Right, that's our DC jack. That would go on there. Oh, nope, that would go on there. So there's our DC jack. However, I'm actually not going to fit this because, as I aforementioned when we started this, we're going to hotwire this with a nice cheap USB power bank, is what I want to do. So we've got our own method for powering that bad boy up. I've got plans for this thing. It's not going to be powered from a USB port. It's going to be powered from a USB power bank. Let's put on our buzzer. And that is the plus. And I'm not going to remove this seal because these things are bar-storially loud. So I'm going to leave it on. Get on there. Make sure that's flat. Ow, I just burnt my thumb. Ah. Cut you short. There we go. Looks like nothing without a beard. You don't have the patience for it, Hokith. Start off with something simple. In a way, this thing will probably teach you patience, really. I find it calms me down. Especially when you're building a kit, because you can't really go wrong with these kits. I've only had one kit that hasn't worked, which I was also really sad about. The kit that I got that didn't work was this thing. It's a screen clock thing. It was cool because it's a really complicated looking kit. And what it's supposed to do, it's supposed to show the time, and it's supposed to show a different message every day. Like, for example, on December 25th, it says, Merry Christmas. And on New Year's, it goes, Happy New Year, and stuff like that. That's what it was supposed to do, but it doesn't work. I put it all together. It's all wired together correctly, but the display is garbled. It doesn't make sense. So it makes me sad. Something simple is complicated. Yeah, that's true. But yeah. Right, what am I going to put on next? Let's turn this thing around the right way. I think we'll put on our battery snap. That's this guy here. That goes on there. I've got some batteries for this because it needs a battery to do its timekeeping. That thing's going to be super awkward. Can I... the legs aren't long enough to fold over. Right, I'm going to cheat on this one. There's a trick when you're putting this stuff together, is if you have... Well, not everyone's going to have this, but I have a syringe of flux. And what I do, I put a little dollop of flux on the legs, and the flux just serves as just a slight glue. Because it's gooey, it just keeps it in place while I solder it, and then the flux just burns up afterwards. Having said that, it's just fallen out. That was a extremely good example. Oh, that's going terribly. You know what, I think I'm just going to have to tin the hole and push it through the hole. And get impatient with it. There we go. Now I've got one in, it'll go easier. There we go. And I'll just reflow those to make sure they're in properly. That needs more solder. Yeah, Lewis Rossman's flux. I like it how you call it a flux pen. He's got a flux hose, has Lewis Rossman. I remember I was reading through some of his comments once, and someone says, it looks like you're not using enough flux there, sort of sarcasm, have you got enough flux? And someone just responded to that saying, you must be new here. Because, of course, Lewis Rossman is notorious for drowning everything in flux. That's the best way to learn. You can't wait for things. Oh, yeah. Oh, it's not so bad, Helkith. Stuff normally takes about 2 weeks to arrive from China. I just order stuff and forget about it, and then things show up in the post. I'm like, what the hell is this? Right, let me just grab a battery so I've got that to hand for when we're done with this. Because also that battery holder looks very small, and I'm not sure if the extremely high quality eBay batteries I bought are the correct size. Oh, I think they are. I think those are going to fit. I think we're going to be all right. Sign of age. Right. Flux is what flux does is it makes your solder flow. So instead of because solder is molten metal, and it will go all blobby and goopy, and just it goes slaggy and horrid if you've heated it too much. And the flux is a chemical a chemical compound that's normally in a sort of this goopy, syrupy type stuff, and it makes everything flow and go nice and shiny and molten and liquidy. So it just makes the solder flow nicely, and you get nice, smooth joints instead of horrible, bumpy things. It's very handy. No, absolutely, Sophinia. These are the questions. These are the important things. Right, let's put some more stuff on our board. What have I got left, actually? I'm running out of components. We've got 2 buttons, and we've got our light sensor and our thermometer. And everything else, I think, is just diagnostic stuff. There's a lot of extra headers on this. Oh, of course, and then we've got the actual displays. So, right, if I put the displays on, we're going to have to commit to that. No, we'll be alright. I'm pretty confident about my my battery power plan. We'll be alright. Okay, so let's put on the buttons next then in that case. So, buttons are going to go there. And they very usefully have bent legs, so I'm going to have to straighten that out. How's that? There we go. Drowning in flux. Yeah. Yeah, you don't really need, if you have leaded solder, you generally don't need any flux. The reason why I have flux is that I also do motherboard repair, and when you get into SMD soldering, which is surface mount, so when you're do I have any examples in front of me? I don't, of course. This has got some surface mount stuff on. This is my component tester that we built on the stream a while back. Where's my tweezers? There we go, so I can point stuff out. So through-hole stuff like this has a leg that goes through the board. So it's called a through-hole component because it goes through a hole. Whereas surface mount is stuff like these guys down here, where they're soldered directly to the surface of the board. And flux is generally required when you're doing SMD work, because you're using very small amounts of solder, so there's very little to work with. Whereas when you're using through-hole stuff, you use fairly large quantities of solder, and the solder itself has flux built into it, which is actually why my solder, if you look, my solder is all bumpy. And it's bumpy because this is ancient and it's been in the sun, and the flux is all bubbled up out of the solder. Like chips and stuff. Precisely that. Right. Let's solder our buttons in place. I'm going to put this in the helping hands because we've got some fairly large through-hole components here that are trying to push themselves around. Trying to be slick and get away. I'm sure I'm crocodile clipping something that I shouldn't be there. And I'm sure it'll be fine. Oh well, credit to George Lee for the handy clips here, because I didn't have one of these, and he got so angry with me not having one of these that he actually bought me one. So these helping hands are called George for that exact reason, and they're actually quite handy. I'm glad he bought them for me. Pretty much everything can be SMD, depending on where it is. And likewise, there's pretty much anything can be through-hole if it's old. Most modern stuff is SMD, but when it's small and cheap, through-hole is still cheaper. There we go. Got some nice tactile buttons there. Oh, that's a lovely sound. Yeah. There's some ASMR for you. I love it. Yes, that's true as well, Anna. Yeah, PC Street. I don't watch much PC building, but certainly it's nice to watch stuff come together. Okay, there we go. Right. Now, before I put on, let me see. I think I'm going to assemble the case because I want to see these sensors will be poking out the top to capture light and stuff like that. So I want to see where the case will sit around this, so I know what angle to put my sensors at. So let's unpackage the case and put this together. How are we doing for time? 1 hour 25. We're making good time with this. Oh no. The problem with these cases is that they've got all of this cellophane on them, which all has to come off. I'm not going to do that right now though, I don't need to. I've got to figure out how this thing works first. Right. Let me see. That's going to be the back of it, because it's got a hole in it that lines up with where that buzzer would go. So which way is going to be up on this thing? That's the top, that's the back. Okay, we've got this the right way around. Just don't put the temp sensor in the corner. Damn it, Hugh! Damn it! Right, that is... See if we can figure this out. That's a push out. That's going to go there. Okay, that's the top because it's got a cutout, so that's going to go there. So it's going to go like that. So actually, if I put those tight to the board sticking up, they'll actually be all right. That's all that's needed. Nice. Okay. Right, is... Oh, critical thing. That goes on the back. Make sure that's lined up. Make sure I put it on the right side of the board as well. That's probably going to have a slight gap. So yeah, that's going to go toward the back. Yeah, it is going to go on the back of the board. Okay. So if we put that in about there, and just bend him up like that, that'll do, right? Right, let's solder one leg. Am I still in focus? Not really. Let's fix that. And reheat. There we go. That'll do nicely. And now this guy, we'll bend it like I would a resistor and put it in place. Go like that. And I'm going to solder that and then bend it up. There we go. Nice. You know. Nice. Okay. I don't want to peel all of these apart, but we have to. Okay, let's put that to one side. I think it's time to put our displays on. And I'm missing one of them. I've got 3, and I've put one of them to one side. Where's it gone? Uh-oh. I've lost a digit. How? How have I lost that? Where could it have gone? How did I manage to lose a display digit that large? How did this occur? Let's take the other ones out for a minute. Oh, it's right in front of me, but it was upside down, so I couldn't see it. It was on the desk like that. And because it was on the desk like that, I couldn't see the big number 8. Streaming is stressful, folks. There's a lot of pressure. Oh, I remember. So here's the interesting thing. The displays actually go on upside down. And the reason why they go on upside down is it means that when this thing is displaying temperature, they can use, those are going to go like that, they can use the decimal point as the degree symbol. So that was one of the sort of funny little design quirks of this thing that I thought was quite clever. Right, let's get that in place. These are nice, these big digits, I like them. I wonder if you can buy them separately. Presumably you can. They don't all go... Oh, you just do it on one, do you? Well... What are they? There's our 10 pin. That one's 9 pin. Hello, hello. Some of our displays are different. That's a 10. That one's missing a pin. Right, let's check the instruction guide. Oh yes, you are absolutely correct, Anno. There we go. According to the instructions, the third Nixie tube, that's apparently a Nixie. Seems legit. Only the third one goes upside down. Yep, absolutely correct. Well spotted. Alright, and I'm using the first one. This is the mysterious 9-legged one. It is missing a leg. Oh my god, can this pin please go in place? I'm going to put this one on the end just in case it's lost its decimal point. Oh, for heaven's sake. I've got to actually bend that by hand. They're actually quite heavy, those pins. I've gone too far in the other direction. Oh my god, this is the worst day of my life. There we go. And fit those back in. There we go. Wonders cease. Right. You know what? You are absolutely correct, Helkith. I'm just going to open one of these up again and just check if that pin is important. And we're going to do it on the one that I just had a mare of a time trying to fit in. Well, rip in pepperonis, because that is VCC main. We've actually got to repair that. That actually needs to be fixed, because that is the positive pin of our display. That display ain't going to work without that pin. Yeah. Well, that's no big deal. We can fix that. It's going to drop in there. And let's stick that in the helping hands, and we'll just reflow all those joints on this one. Let's see. I'm just going to redo the rest of them. Just for good measure. They're pretty shoddy, these things. There we go. I'm not going to do that for every single one of them. However, that guy is now fixed. Does that go on the right... I need to check if that's the right way up. Nah, I'll be impressed if I manage to lift the pad anyway. Not on a through-hole board like this. Where's the decimal point? It's there. So that needs to go on like that. And Hugh, I agree. I don't care for pomegranate either. We have something in common. Right. Where were we? That's the top. That's the first one. I've turned this thing over so many times, I'm losing track of which way is up. Got to get all these pins to line up at the same time. There we go. Right, and at long last we can actually solder a display into the board. Arrgh. There we go. Now, I should have done my power pins first. I have a plan for that. We'll do that later. I'll solve that in a minute. Right, let's get the rest of our displays on. Right, then the next one goes upside down. Gin. There we go. Oops, jogged the camera.
You have no limitations, no drawback.
Acrylic paper, why not use some sellotape to peel up the edge? That's not a bad idea.
The real world kind of stings.
I've never thought of doing that. I might give that a whirl.
Under the guise of my makeshift world built off my ideas, my thoughts.
Should be okay, Hellkith. I'm quite surprised that first pin broke off. I think it was just a dry joint. Whoa, we did bend that guy though. We don't want to bend him too many times. Let's just reorient him. That'll snap off if I bend that too many times, which will be a bit of a bummer. We can fix it if that happens, but we've got to be careful. Right. In comes the soldering iron. Whoop. Get along these. Everything's at a weird angle, but I'm trying not to block the camera's view. Oh, solder. I quietly get high on flux fumes. Whoop. Whoops, there we go. Bridging everything together there, but there we go. We're fixing these bridges as we go. I'm carrying a big blob of solder on the iron at the moment just to make things a bit quicker. There we go. There we go. Let's just tidy those up a bit. Get rid of some of those spikes that I left in there. No, that'll do. It's not going to fall out. Yep, I'm okay with that. You're having fun, Hugh. And are they? Yeah, they're flat enough. That's alright. I'm happy with that. Cool. Right. I might have to, you're right. We'll find out. We're very close to that point. It's time to put in our chips. So I'm going to bend these guys. Tell you what Clive did have that I really want was his official chip leg bending machine. I was very jealous when I saw him pull that out. A little clamping tool specifically for bending chip legs for insertion. There we go. There's one. And And silver unit. Urgh. Do you mean that or that? That's a battery holder, that's a buzzer, and that is our clock crystal. Yep, that is a clock crystal. So it oscillates and it provides a frequency reference for the clock to tick on. So that is a quartz crystal in there. Do I need to bend those a bit more? I think I do. Yeah, needs a bit more. $32, will it be that high? I haven't seen anything otherwise, so you may well be right. Fair enough. Oh wow, these legs are still too far apart. The force is strong with this one. Let's give it a bit more. There we go, I got a bit vicious with it that time. Okay, that's out except for a couple of legs. Let's just guide that in. There we go. Get in there. There we go. And they can divide it down to 1 sec intervals. Ah, yes. That does make sense. Good. Right. This thing is ready to power up. I've just got to solder some power leads onto it because I've deliberately left off the power jack. Where's my battery collection? We've got to put a little button cell in there. Which way up is that going to go? It's going to go that way up. There we go. Okay, so now that goes that way up. There we go. I was very confused for a moment. Okay, so now we need some power fly leads. So I'm going to get some hookup wire, and we'll just put some jumper wires on it for now, because I can tidy it up when I've figured out exactly what I'm going to do with it. So let's have that, and try and get a black one that's roughly the same length. And that. And I'm just going to strip these. So this is just ordinary hookup wire. Very handy just for wiring stuff up, basically. Been using this at length lately to make a custom LED lighting system for my shop. Video to follow. Check out my YouTube in the next 2 weeks or so. Okay, right. Those two are common together, which means those are the negatives. So that's our negative rail, and that's the positive. So I'm going to tin that bit up. 2 years? Rude! I'm pretty good at the moment, I'll have you know. I've been very good with my release schedule. It's not fitting in the hole. Okay, I'm going to blob that. There we go. Good enough for Australia. I'd better tin the other wire first. I will neaten this up when I've figured it all out. Yes, that is why. What? Well, is it 40% lead? Yeah, I thought it was less than that. I thought there was actually almost no lead in it. That's classic solder, yeah. Unless you're using unleaded solder, of course. Power. Right. Let's unplug that a sec. Set my power supply up. Right. 5 volts. Yeah, we've got 5 volts to the power supply. Here goes nothing. Oh, it's green. Okay, right. You guys can't see a darn thing. Where's my thing? I thought it was going to be white. Oh, I remember. I specifically bought the green one. There we go. Let's turn off some lights so you guys can see it running. It is doing something. First digit isn't doing anything. You're correct. Right, so we're missing one. That was the one with the dodgy anode, wasn't it? I'm assuming... Oh! Okay. Okay. It's 9,200 hours, ladies and gentlemen. Right. Okay, so what's going on here is this is because the device has been reset. The timer chip has a small amount of memory storage in it, and because the timer chip has been reset, the CPU does not have any kind of routine in it to reset the timer chip. Therefore, the timer chip just has garbage data in it. So it's returning garbage data as a reference point. So when we set the time, this should actually make sense. So what we need to do is just set the clock. I don't know what it's doing, but we're getting there. So if we set the time, that should start making a bit more sense. So, right, let's see if we can make sense of the instructions on how to set this thing. There's the setting part of the video. I don't want to watch the video. Do we have to? Right, hang on a sec. Set up hour, press function key. Oh man. Big Clive wasn't kidding. These instructions are bonkers. Allow me to read you an excerpt from the instructions. Right. Set up time, alarm clock, hourly chime. Set up hour. Press the function key, the hour Nixie tube and the second point are blinking. Press plus key to revise hour. Okay. I'm holding it down, see if that does anything. Nope. Okay, we're cycling through stuff here. Okay, let's try. Okay, right, so let's try that. Right, so what's the time at the moment? It's 2100 hours where I am. Let's just make sure this counts through 24 hours. 3, 4, yeah, there we go, it is working. 21 we want. Although actually, why are we counting minutes? That is true. Okay, right. We want 5. I've gone round. Let's cycle through it all. One, 2, 3, 4, 5. Okay, right. What is this? Does it count to 31? Oh, that counted to something. Hang on a sec. That was 24. This must be the alarm. Yeah, that's the alarm. Okay, let's set the alarm to 12 o'clock, because that's when I go on lunch. There we go. Okay. What does this count to? That's 24. Okay, that's something as well. Let's set that to 12. Right. So now we've set the time, we now seem to have an actual time display. Zoom out a bit so you guys can see a bit better, hopefully. Right. It's 21:06. Oh yeah, time is passing. Oh yeah, okay. A minute passed just as I was looking at the clock. Whatever. Whatever. Okay, right. So what happens if we go through this now? We've got 8, 15:31. Can I set that? I can. Okay, here we go. Here's the date. So it's the 12th month. And it is the 13th day. Seven. Oh, days of the week. Where are we? Thursday. Right, so Monday is the first day of the week. Fight me, America. Tuesday, Wednesday, Thursday. So what's that? 23 degrees now, apparently. Okay, there we go. So that's 23 degrees. So let's see if our temperature is working. And to see if the temperature is working, I'm going to fire some hot air at it. Yes, the temperature is working. Nice. If I blow on it, the temperature comes down a bit. Yeah, this probably needs calibrating. Bearing in mind, the whole thing has been soldered. The board itself has got a lot of heat in it where it's had the soldering iron on it. So there's probably a lot of ambient heat in the whole thing. So, right, see, the 2 dots, not yes, it's required so you can see. Oh man, if I take that off, you can see there's a little bit of shimmer on the multiplexing. Looking at it with my naked eye, I cannot see any flickering at all. But the camera is seeing just a little bit of shimmer. Oh, it's actually not coming through on the stream. That's interesting. On my raw output, we can see it. What does my 30 frames camera say? Oh, no, the 30 frames camera does not see the flicker. That's interesting. That's kind of cool. Yeah. Right. Okay, let's go back through to the time. Cool, that works. So, now let's get the case ready for it, and then we'll power it from our cheap power bank that we took apart. So,